In this example, we're to sketch a graph of the following quadratic function. That function is f of x equals negative x squared plus 6x plus 10. So before we even do this, we know lots of things about this. We know the y-intercept is at 10. We know that it is concave down from the information that's there. Now, how do we find more points? Well, to find more points, we can do what's called partial factoring. So to do that, we're going to take only this part. And the reason why we're going to do that is because the minus x squared plus 6x plus 10 cannot be factored. So we're going to do something called partial factoring. So when you pull out the negative x from both of those terms, so whatever the number is that's right here, we can pull that out. In this case, it's a minus 1x. So we're going to pull that out, and we're going to be left with a positive x because we pulled out the negative. We're going to be left with a 6 here, and the sign between them will be a negative because we're pulling out the negative from the positive 6x. So once we have that, we make each one of those factors equal to 0. So we have negative x equals to 0, and of course that means that x equals 0. We have x minus 6 equals 0, and that would mean that x would equal 6 because we add 6 to both sides. So from there, that gives us some points. It gives us that the f of 0 equals 10 and the f of 6 equals 10. So the points would be 0, 10, and 6, 10. That would be our points. Now, because of symmetry, that's going to tell us a lot. So when we graph it, we know automatically that we have our 2 points here. And we would know that the axis of symmetry would be in between those 2 points. We also know that the vertex would be up here somewhere because it is concave down. Oh, that's a bad drawing, but that's okay, I can get rid of it. So how do we find the axis of symmetry? Well, again, we know what the x values of the 2 points, and because they're symmetrical, we know the average of the 2 x values would give us our axis of symmetry. So we have 0 plus 6 is 6, divide that by 2 and you get 3. So our axis of symmetry is x equals 3. So the equation of the axis of symmetry is x equals 3, and that's the equation of a vertical line. Somewhere up here will be where our vertex is, and we know that again because it is concave down, and it's going to pass through these 2 points that we know already, which means it's going to have x-intercepts over here somewhere. So we know all of that just because of the shape of a parabola. We know this information. So what do we do next? Well, we know that the x value of the vertex is 3 because it's on the axis of symmetry. It has to be x equals 3. So if we substitute 3 in for x into this equation, we'll find out what our y value is. So all we have to do is write out our function, substitute 3 in for the x, and we'll get y equals 19. The f of 3 equals 19. That means the y value is 19. So that point would be, well, on my drawing I have 10 here, so about twice as much. That means our vertex would be about there, and that would be the point 3, 19. So now we can draw. We can draw our sketch and finish it off. So there's our 319, and now we draw. And this time I drew it a little bit more careful. And our shape looks something like this. Now I don't know what my x-intercepts are. I'm not asked for that in this question. But that is a very nice sketch of this quadratic function. Now the last question is, what is the domain and the range? Well, the domain is what are the x values allowed to be? And with all quadratic functions, x can be anything. X can be all real numbers, which means it will continue as far to the left and as far to the right as it wants. The y is where your restriction is. So we couldn't have a point up here because our y value has a maximum of 19. So how do you write that? Well, your x is an element of the real numbers, and your y must be less than or equal to 19, and it is still an element of the real numbers. So that is how you would do the domain and range given a quadratic function.